Greetings to the sir. My name is Kajal Kumari. I am presenting on behalf of my team members. My fellow team members are Sadhvi and Chiranjeev. Our project is mainly based on genetic algorithm. Our problem statement is determine the optimal order to visit the malls for shopping to maximize the discount with minimum given time limit. Genetic algorithm gives an optimal solution, not accurate solution. There are various points that needs to be discussed. Consider before proceeding, that is optimizing the given problem using genetic algorithm, considering time limit as fitness value, and corresponding discount will be the convergence condition. Here, if we are visiting any mall, it will be represented by 0. It will be represented by 1. Otherwise, it will be represented by 0. Collection of 1 and 0 will form genome chromosome. There are various phases in genetic algorithm like initialization, selection, crossover, and many more things. Here, initialization in which we initialize random population and we find corresponding fitness value according to that population. Here, I am going to give a brief overview of the code. Later, the code is explained by my team members Chiranjeev and Sadhvi. Here we need a database. Here we need a database for our project. That is, in this, the first column represents the shop number, the second column represents the shop name, the third column represents the time from initial position to the shop, and the fourth column represents the discount given by the shop. In the code, we create a genetic class in which in public section we declare variable like genome, total time, discount. After that, we declare a constructor for initializing the variable, that is total time and discount. After that, we use a friend function, value compare function, to compare the value, and we later define the output function, that is defined later in the section. After that, in integer main function, there are various variables that is defined here, that is shop number, discount, random, string shop number, shop name, shopping time. After that, we have to consider database size and time input. Here we enter the size of testing database, that is the size we want to enter in the section, and after that we create the range, that is a problem space, which is the 2's power of n. After that, we create an array of object of genetic class. After that, we enter the maximum time, that is the fitness time or maximum limit time. Here we have to open the database in read mode. After successfully open, it will go further. If it not, it will give output failed and it will return from here. After that, we declare two string variable, that is next generation and offspring. After that, we generate a parent function here. If the optimal solution is not found, then the loop will execute till generation gen, and if the optimal solution is found in between, then it will be good. Here, after that, a random number is generated from random function in the range of limit. After that, from that generated random number, a binary number is created using bitset function. After that, it is converted into string, and then it is stored in genome. Here we are reversing the string because we have a string of 0001, which refers to database as mi. After reversing the string, it will represent Samsung, that is 1000. After that, CG pointer is used to move the pointer to beginning of data after iteration. After that, a fitness value is generated. Fitness value is generated for this function, in which we give shop number, shop name, time and discount, and if the chromosome value is 1, then we consider that chromosome and add the total time and discount. After that, if the corresponding genome's total time is greater than the swapping time, which is maximum time limit given, then its total time will be set to 0. Otherwise, if the total time is less than the swapping time, then it will be give the fittest solution. After that, we sort the list in descending order respective of time. From here, the next presentation will be given by Chiranjeev. Chiranjeev, please proceed. Thank you, sir.
Greetings to everyone. Thank you, Kajal, for handing me over. I'll be explaining about subsequent phases like selection, crossover, and mutation. For new generation, we take two genome named as offspring in selection phase, then crossover it. For explaining crossover in simpler terms, we take an example as in which we consider two genome A and B having the value 11 0 0 11 0 0 10 10. Then the length of the genome, which is 4 in this example, divided by 2, stored in half variable value index of genome A, where index is smaller than half, will be replaced by B genome of corresponding B index. And then here, as an example, here the crossover happens and the first genome A becomes 1110 and the genome B becomes 1000. Vice versa for genome B. By this, we have achieved single point crossover. In mutations, crossovered offspring will be passed in mutation function at random index of that offspring genome. If random probability is greater than 0.5, 0 will convert into 1 and 1 into 0. Here as an example, the genome A is 1010 and after mutation at index 3 it became 1000. Now we come to the code part. In the code, the return type of the crossover function is string. In this function, we are passing two parameters, genome A and genome B of string type. If the length of genome A is less than 2, then simply return A. In the else part, we are storing the size of the genome A in the int half. If half is less than or equals to 1, then simply return the string A. Now we are taking a string temp and putting the genome A in temp. Now we are running here the loop to put the half part of the genome in the temp and then simply return the string temp. Now in the mutation part, here the return type of the mutation is string. We are passing any genome A to be mutated, storing the length of A in X. Now taking the random index of the string and storing it in int no. Then we are taking any random float value and storing it in R using random function and srank function to generate the random value probability between 0 and 1. Here if R is greater than or equals to 0.5, then at the index new of A of genome A is equals to 0, then it will be converted to 1 or mutated to 1 and return the mutated genome and if it is 1, then it will be converted to 0 and return the mutated genome at end. That's all from my side. Further explanation will be given by Sadhvi. Thank you, sir.
Greetings to the faculty members and my team fellow. I will be summarizing all the points mentioned by Chiranjeev and Kajal. Starting with the int main, variable is defined, database size is given. As mentioned, testing database is having size 10, but we can take any size in between 10 to compute the genetic algorithm. Then the limit is population Population problem space is generated, which is having power of 2 to the power n. Array of object is made in the limit. Then the parent generation is generated till the gen when the limit is gen. It specifies that if we found the optimal solution, then we break through. But if we don't find the optimal solution, then maximum time our generation can go through is up to the gen, which is mentioned above 100. Pardon for the mistake. This is our parent generation. Parent generation is initialized between parent can be between the problem space. It cannot be zero, as the our optimal solution cannot be zero in any case. We can visit at least one shopping mall, so it can be can't be zero. So we are starting by 1 to the limit. Here fitness value is generated. Fitness value is generated in the terms of total time of the respective genome. It is the summation of the total time we have started to commute from each and every showroom. And corresponding discount is also the summation of the total discount given by genome. If our total time for a particular genome is greater than our time limit specified, then we set the total time equal to 0. Why we are doing this? Because we are sorting our array of genome in descending order. So by this we get the best fit solution in the starting range. Doing things will reduce our chances to getting the genome which are having the values total time values greater than our shopping time. It remains stagnant below. And our convergence condition is like that. If our previous is a integer type variable, we store the previous genome best fit previous genome discount. As in initial condition there is no previous discount, it will be it was initialized by equal to 0. If our population size, and each iteration we are dividing by 2, so we are reducing the population chances by 2. -1 is for the population we have already generated in terms of parent. So we have stored the G0 genome in offspring and G1 genome in offspring 1. We have crossover the generated result first is stored in offspring 0, and similarly it is stored in offspring 1. Then offspring 0 is further passed to mutation. Crossover doesn't guarantee that the variation has occurred or not. So we need mutation to ensure that variation is occurring. Offspring 0 mutated result will be stored in offspring 0, and similarly mutation offspring 1 result is stored in offspring 1. Even in any case, if mutated result is equal to 0, as we are considering 0 is our best fit result, if that result is 0, which simply means we are not visiting any shopping mall, then in that case there is no need to update next generation. Simply skip the loop. So here we are, if it is not equal to 0, simply update the next generation with offspring, and next generation is further parent generation is further updated by next generation, and it is further one more time sorted in descending order, as we are getting crossover and mutated result in each and every iteration. Further we are here representing the generation value. How many generation we have iterate over go through our code to get the optimal solution. The best fittest result is stored in next generation zeroth element, because we are sorting our genome array in descending order. So we have stored in answer string, and so as previously shown, our win fitness loop, similar to that, we have reversed the string to correctly hover through our database. If we don't, it will iterate from the last limit to the beginning of the database. And 6G is used to point to the beginning of the database. If we have a genome value 0, 0, 0, 0, 1, suppose, then in every at every time whenever we have 0, it only read, it doesn't print. Whenever we have get 1, then it simply prints shop name. Here is the output. At generation 3, we have found our visiting store, which is Vivo and MI. Thank you all for having